Hello everyone, I am Shujata Kundu, Assistant Professor of Department of Information Technology of Narula Institute of Technology. In the previous lecture, we have already discussed about the different types of normal forms like first normal form, second normal form, third normal form and Boyce code normal form using examples. So I hope all of you understand the concepts, because you can see that if I want to move on to another normal form, it must hold the condition of the previous normal forms. Because if a relation is in second NF, it is in first NF first, right? A relation is in third NF, it is in second NF also. A relation is in Boyce code normal form, it is in third NF also. So you can see that means when we are going to higher levels, it holds the conditions of the lower levels also, or the previous normal forms also. Then we can move on to the next onwards. So I hope all of you understand the concept of all these four normal forms, and these normal forms we have explained using the functional dependency, single valued functional dependency. Today we will discuss the concept of multi-valued dependencies. Let R be a relation having attribute A, B and C. That means R is a relation which has the attributes A, B and C. There is a multi-valued dependency of attribute B on attribute A if and only if the set of B values associated with a given A value is independent of the C values. So a relation, first we have considered a relation R which has the attributes A, B and C. There is a multi-valued dependency of attribute B on attribute A if and only if the set of values associated with a given A value is independent of C values. So then we can say there is a multiple dependencies, right? For a dependency, we all know about the concept of single dependency. That means in single dependency, B is dependent on A if for a single value of A, that is in single dependency. Multiple value of B exists, then the table may have the multi-value dependency. That is the difference. That means in single valued, there is the dependency of single value dependency. That means one value of B can be uniquely identify the value of A. Whereas in multiple dependency, there the multiple dependency condition or concept hold. That is, with the help of one value of A, we can find out or we can determine multiple value of B. That is the concept of multi-valued dependency, and it is denoted by this symbol, that is A double arrow B. Single arrow for single value dependency, double arrow because there is a multi-value dependency. So we can write this as A double arrow B and read it as A multi determines B. Okay, A multi determines B. If R has at least three attributes A, B, C, A, B and C, then we can write if B is multi-valued dependent on A, then C is also multi-valued dependent on A as well. The dependency A double arrow B is called a trivial multi-valued dependency if B is a subset of A, or we can write A union B is for all the relation R. Now we are ready to consider the fourth normal form. So next we will discuss the concept of fourth normal form. a relation is in fourth normal form, that means 4NF is a level of database normalization where there are no non-trivial multi-value dependencies other than a candidate key. It builds on the first three normal forms, that is in first NF, second NF, and BCNF, and third NF, and after that the voice code normal form also. That means it builds on all the previous normal forms. It states that in addition to the database meeting the requirements of BCNF, that is voice code normal form, it must not contain more than one multi-value dependency. So a relation, basically the fourth normal form means a relation R, you can write, or a relation is in fourth normal form if both the following condition hold. These are, it should be in voice code normal form, that means it will hold all the previous normal forms conditions, first NF, second NF, third NF, and BCNF, and there are no non-trivial multi-value dependencies. If these two conditions satisfied for a relation, then we can say that the relation is in 4NF. So for explaining this concept, let's take a look on a example. So first we have taken a example of relation. Consider a relation project work. We have taken relation project work. The relation name is project work, and we assume that first of all, in project work we have the attribute programmer. That means here we will store the information about the programmer. Those will do the projects. Then we have the attribute project. It will hold the information about the project. Then the information about module. That means this is the information about the project module. So we assume that a programmer can work any number of projects. That means a programmer, you can see in this relation also, a programmer P1 or working in project 1 in module 1, and a programmer working in another project 3 of and in module 1, that is module 1 of project 3 and module 1 of project 1. So programmer P1 is working in two projects simultaneously. So we are assuming that a programmer can work on any number of projects, that is multiple number of projects. And we are assuming that a project can have more than one module. That means in this relation you can see that the project 1 has module 1 and project 1 has module 2. That means in project 1 we have two modules, module 1 and 2. Same for the project 3 also. Project 3 also have two modules, module 1 and module 2. So we are assuming these two constraints, that is one programmer, that is one programmer can work on any number of projects, that means multiple projects, and a project can have more than one module, like this. A table with multi-valued dependency violates the normalization standard for fourth normal form because it creates unnecessary redundancies and can contribute to inconsistency of data. To bring this up to 4NF, that is in fourth normal form, it is necessary to break this information into multiple tables. So we can see that the dependencies for this relation is project dependent on programmer and module dependent on project, because depending on the projects we can they have the modules, because in one project maybe there is a 2 module, maybe there is a 1 module, maybe there is a 3 module, like that. So module is dependent on project. So this relation is multi-value dependency, because for a single value of project there is multiple value for module 1, module 2. Same, there is a multi-value dependency of project and programmer also, because one programmer can work on multiple number of projects. So for P1 single information of a single programmer P1 has participated or working in the multiple projects, project 1 and project 3. So project is also this dependency is also a multi-value dependency, because for a single value of programmer can determine the multiple value of project, more than one value of project. So this is a multi-value dependencies. So these are the dependency for this relation. So now we will check the conditions for the anomalies. So if we want to delete the project information of project 2, if we delete this information, you can see that automatically we will delete the information about the programmer P3, because there is a single programmer P3 who is working in the project 2. So if I delete this information, it will automatically delete the information about the programmer also. That means if I delete project information, it will automatically delete the information about the programmer. So there will be loss of information. So there is a deletion anomaly. Suppose we want to add a new project information, project 4. So that is also create a problem, because if I want to add a project information in this table, simultaneously we have to add the programmer information over there. So if I want to add a new information in this table, there will be a problem for that, because simultaneously we have to insert other informations also. So until we are assigning any programmer to the project, we cannot add any new project into this relation. So there is a insertion anomalies also. Suppose we want to change the name of the project. Instead of project 1, we want to change it to another name. So if I want to do it, there will be also a data inconsistency. There can lead data inconsistency, because there are multiple rows, those hold the same information of project 1. There are multiple programmers those are working in the project 1. So if I want to update the project information of project 1, then we have to update all the programmers, all the rows individually, all the programmer information individually, because they are also working on the project 1. So it can also create data inconsistency. So there is a problem for updation also. So we have to remove all these anomalies, deletion, insertion and updation anomalies, to make this relation is in 4NF. And the solution for this is, you can see the solution for this relation is, we have to divide this relation project work into two relation, that is project and project module. We have divided two relation, that is this will be programmer project and this is project module. We have divided the previous module into two modules, that is programmer project and project module. And when we divided the original relation into this relation, you can see that it holds all the dependencies, that is project is dependent on the programmer and module is dependent on the project. So we preserve the dependencies, as well as we have removed all the anomalies from this relation also, because if I want to add any project information, there will be no issues to add the information, because we don't need to add the information about the programmer. If I want to delete any information about a programmer, we can easily delete it, because it will not delete the information about the project. As well as if I want to update any information of project, then we can easily update, there will be no problem. So we can remove the anomalies from the previous table when we divide that table into these two tables. So now this relation is in 4NF. Next we will discuss a very important concept, which is joint dependency. Joint dependency or joint is of basically joint dependency is a further generalization, or you can say a joint decomposition is a further generalization of multi-valued dependencies. if the join of R1 and R2 over C, that means over a attribute C, over a relation, not attribute, R1 and R2 are the two decomposed relation of R. And if I join R1 and R2 and we get back C, and C is equal to the relation R, then we can say that a joint dependency exists. That means if I decompose a relation into multiple relation, and after that if I apply the join between all those decomposition and it make a new relation which is equal to the original equation, then we can say that it is a joint dependency, or there is a joint dependency exists, where R1 and R2 are the decompositions of R, where we have taken the attributes like, that is R1 have the attribute A, B, C, and R2 have the attributes C and D of a given relation R. R has the attribute A, B, C, D. So the original relation is R, which has the attributes A, B, C, D, and we have divided this relation into two relations, R1 and R2. R1 have the attributes A, B, C, and R2 has the attributes C, D of the given relation R. So we can say that R1 and R2 are lossless decomposition of R if it's hold the joint dependency. Then we can say R1 and R2 are lossless decomposition of R. I hope all of you remember the concept of lossless decomposition, which we have already discussed in previous lecture when we have discussed the concept of decomposition. So the relation R1 is A, B, C, has the attribute A, B, C, and the relation R2 has the attribute B, C, and D. And if I decompose if I join this R1 and R2 together, we will get back the relation R again, and it is the concept of joint dependency. Okay, so using this dependency, we will discuss the concept of the fifth normal form, or we can say projected normal form 5NF. A relation R is in fifth normal form if and only if it satisfies the following conditions. And the following conditions are: R should be already in fourth NF, that is fourth normal form, and it cannot be further non-loss decomposed, that is it hold joint dependency. A relation R is in 5NF if and only if every joint dependency in R is implied by the candidate keys of R. A relation decomposed into two relations must have lossless joint property, which ensures that no spurious or extra tuples are generated when relations are reunited through a natural join. So then we can say it is in 5NF, and it will satisfy, or it will hold these two conditions. That means R should be already in 4NF, that means it is in first NF, second NF, third NF, and this NF. Then it is in fourth NF, and it cannot be further non-loss decomposed, that is it will hold the joint dependency. Then we can say that this relation is in 5NF. Now we will explain an example. Consider the below schema of the table ACP, that is Agent Company Project. The name of the table I have given ACP because I have taken the attributes agent, company, and product. So the initials of all these attributes together, I have given the name of the table. So in this table we have three attributes: agent, company and product. If in this schema we can see that that is, if a company makes a product and an agent is an basically agent column or agent attribute is an agent for that company, because we have the information about a company. So if a company makes a project makes a product and there is an agent for that company, then he always sells that product for the company. That means company will produce the products and agent will sell all those products to the customers. So under these circumstances, this table ACP, the relation ACP is basically have the values like this, the attributes like agent, company and product. So you can see that if I know only the information about agent, it is not possible to find out the company details and product details, because one agent working in or selling different products or working in different companies. So using the agent we cannot identify any company information as well as only product information. So if I want to make the primary key for this, agent and company together we can make the primary key, because if I know the agent name and company name, then we can find out the product name. But there also there is a problem, because a employee working in a company but selling multiple products, so there is multiple valued dependencies, because you can see for individual value of agent and company we have multiple value of the product. So product is multi-valued dependent on this company and project. So the relation is in, you can see the relation ACP is again decomposed into three relation. Now the to make this relation is in 5NF. So if I decompose this relation into three relation, that is table 1, that is R1, relation 1, relation 2 and relation 3. In relation 1 has the attributes agent and company. Relation 2 has the attribute agent and product. Relation 3 has the attribute company and product. So if I divide the first table, previous table into this three table, now we have to check the joint dependency, because if it holds the joint dependency, then we can say that it is in 5NF. So the result of natural join of R1 and R3 over company, you can see R1 and R3, and we can do joining between these two relations with the help of company, because this is the common attribute between these two relations. So if I want to join, we can join using this common element. So the result of natural join of R1 and R3 over company, and then the natural join of R13, that means if I join these two tables together, we will get a new table, that is R13, and the natural join of R13 and R2 over agent and product will be the table ACP. If I get back the table ACP, then this holds the concept of joint dependency. Hence, in this example, all the redundancy are eliminated, because if you divide this table in this three part, there will be no redundancies. There is no redundancy, as well as the decomposition of the main table, that is ACP, is lossless joint decomposition. Therefore, this relation hold all the normal forms condition. It has hold the condition for first NF, second NF, third NF, 3NF, 4NF and the joint dependency also. So therefore the relation is in 5NF, as it does not violate the property of lossless join. So a relation is in 5NF. I hope all of you understand the concept of normalization with the help of all the different types of normal forms. Then we will do the classes. Then we will discuss all this elaborately with different examples. I hope all of you understand the concept of normalization. So today we have finished the syllabus of module 4. Thank you.